Graphs can be also translated vertically. We've given an example of that already, but recall that the graph of y equals x squared plus 5 is a graph of the parent function y equals x squared shifted up 5 units. We can also translate vertically through a vertical shift, so there's not a fancy name like phase shift for vertical shifts. It's just still called vertical shifts. So if you look down here at the examples, y equals sine of x plus 4. Notice that the plus 4 is not grouped with the theta. That means it is a vertical shift up 4 units since it's a plus 4. Y equals tangent theta minus 3. Again, the minus 3 is not grouped with the theta, so that is a down 3 shift. When a trig function is shifted vertically a number of k units, the line y equals k is the new horizontal axis about which the graph oscillates. This line is called the midline. It can be used to help draw vertical translations. What that is saying is that a horizontal axis will shift up and down just as the vertical shift occurs. So notice that the reason that's important is because the high point and the low point aren't necessarily opposite signs, same number. It's not like saying that if the amplitude is 3, we go up to 3 and down to -3. Because notice the highest point is much higher of the x-axis than the lowest point is below the x-axis. But they are also both the same distance from the midline, which is the shifted horizontal axis. So we can use that information to graph vertical translations. State the amplitude, period, vertical shift, and equation of the midline for y equals half cosine theta minus 2, then graph the function. So the amplitude, the a value is only 1/2. The period will still be 360 since we're dealing with cosine divided by a b value of 1, which is 360. Vertical shift, there is a shift. Since there is a -2 that is not grouped with the variable, this is a shift of down 2 units. And since the shift is down 2 units, the midline will be now located at y equals -2 for shifting down 2 units. Excuse me. So I'm first going to graph the parent function. Parent function is going to be y equals 1/2 cosine of theta. So 1/2 cosine of theta will be starting at the high point of only 1/2 of a unit. 360 degrees later, still at the high point, back at the high point. Halfway between the highs is the low point of -1/2, and then the intercepts at 90 and 270. So here is 1 full unit of that, or 1 full period of that. But now I'm going to shift all of those points down 2 units. A fast way of doing this is take the x-axis, the horizontal x-axis, and shift it down 2 units to the line y equals -2. I'm going to draw that in blue because this will be used to help us find the actual graph of 1/2 cosine theta minus 2 after the vertical shift. So if I take this point right there and move it down 2 units, so that would be 1, 2, and it places it right there. And I could do that with each one of those points by moving it down 2 units. Or what I could do is just look at the midline and notice that the 90-degree point is on the x-axis. That means after the shift, it is going to be on the midline. The 180 point of the original red function, parent function, is 2 blocks below the x-axis, so the shifted function will be 2 blocks below. And continuing that same pattern, this is what the final graph would look like after the shift. So hit through all those points, and then there's 1 full period after the shift. If I wanted to continue the pattern, it would look about like this. State the amplitude, period, vertical shift, and the equation of the midline for y equals tangent of theta plus 3, then graph the function. Now this one is a tangent function, so a little bit different. starting with the amplitude, because there is no amplitude. Because tangent does not have an amplitude. It doesn't have highs and low points. The period is also different because the period is based upon 180 degrees, so that would be 180 divided by the b value, which again is still 1. That's 180. Vertical shift. I do see a +3 that is not grouped with the x, so there is a shift of up 3 units. And then the equation of the midline, since we're shifting up 3 units, the midline is located at y equals 3. So going to the parent function, which will just be y equals 1 tangent of 1 theta, or just tangent of theta. When we graph tangent, we first graph the asymptotes. So the asymptotes are found by taking 180 over 2 times b. Since b is 1, that's going to give me 90. And then we will do odd multiples of 90. Remember, that means like -1 times 90. There's an asymptote at -90. +1 times 90 places an asymptote at +90. The next odd multiple would be 3 times 90, which would be at 270, and so on. So I will have asymptotes at -90, +90, 270, and since I do have room, I do have an asymptote at 450 because that is going to be 5 times 90. So the parent function is going to look about like this. Remember what the parent function looks like. It's right next to the asymptotes. It's going to hit the x-axis halfway between the asymptotes. And since we know that this tangent of 45 is 1 and the tangent of -45 is -1, I can use those points too to help get a more accurate representation of the graph. So the graphs are going to look about like that all the way through. So that's the parent function. However, we are graphing the new function, which has been shifted up 3 units. So I'm going to start by graphing the midline as a dotted line in blue, shifted up 3 units. Don't confuse that with an asymptote. That is the midline because we are going to cross the graph, but I'm using that to help me graph my final answer. So the asymptotes, since they are vertical asymptotes, they are not going to shift up or down because vertical asymptotes are already gone forever. So all these points that I used to help graph the parent function, I'm going to use those to graph the new function. So I will put a point on the midline halfway between the asymptotes and then draw my final tangent function through those. So my final tangent function will hit the midline halfway between the asymptotes and look about like that.